Okay, so hello everyone, this is Akshay here. Let us continue with the today's GFG period week. But before proceeding ahead, so let us follow our tradition that to give a shout out to a person who have achieved something in our journey to code. So Prem here has completed 150 days streak. So congratulations, Prem. Way to go, and it will definitely worth it in the long run for you. So yeah, great work. So let us continue with the today's streak. So today's question name is Pascal Triangle. And one more thing that yesterday the question was on AVL tree insertion. I have not made a video on it because it was way too hectic for my time management, and as well it's a very deep concept. I need uh, a good time to make the video on it, right? So definitely in the future it will be coming up, so do not worry. If you have solved it, well and good, but definitely it will be coming up in the future. So given a positive integer n, so we need to find the nth row of the Pascal triangles, right? And one more information that this Pascal triangle is a very standard problem. So this is the building block of solving and another great question, another great standard problem of NCR, right? So after solving this question, if you have not solved the NCR, that video is already up there in my PhD streak of day 242. You must go through it, right? After doing this question. Great. ठीक है, तो Pascal triangle क्या होता है यार कि we have been given this is the Pascal triangle, so 1, right? And then we have 1 and 1 again. So again, so we have 1 here and we keep on uh, reducing the sum of the above two states from the above rows, right? So it will be 2 here, and again not here, the 2 would be here, and then again last value would be 1. Similarly for the last value would be 1 again, then this sum would be present here and this sum would be present at this side, and then again, right? So for n equals to 4, it is asking me to return the nth row, right? So if you visualize it like this, if you visualize it like 2D array, then you'll be able to get it more it will make more sense. So what you have 1, and then let's say you have 3 zeros, correct? And what are we doing is that we are, let's start from this, the last hmm, the last value, correct, or say the last column. So we need to return the sum of these two last values. So it is 0 again, then again if you just sum this up, it would be 0 again. If you sum this and this value, it would be 1, right? And this 1 will remain here. So for all the rows, 1 would be constant, and then again we'll go to the last pointer and we'll get the value of ith index and I minus 1 index and update it to the ith index, right? So 0 again, so 1 plus 0 would be 1 again, and 1 plus 1 would be 2. Similarly again we'll do the same task starting from the last column. So 0 and 1 is 1, 2 and 1 is 3, and 2 and 1 is 3 again, and you need to return this row, right? So how it is related to NCR here? So it is related to NCR like this. So let's say this is the uh, row 0, this is row 1, this is row 2, and row 3, right? So these values are nothing but 0c0, and then you have 1c0 and then 1c1, and then you have 2c0, 2c1, and 2c2. Similarly you have 3c0, 3c1, 3 3c2, and 3c3. If you solve the values of these particular NCR, then you'll get these particular rows, right? So that is what we have covered in day 42 242 as well, right? So this is the basic crux to form to solve the question for NCR as well. Great. So this question is very easy. So as we have done the dry runs, what we need to do is that we are having 4 rows here, right? So it is 0 1 2 3, and then this index is as 0 1 2 3. So let us name this row as I with ith pointer, and let us name the column with the jth pointer, right? So what we need to do is that we need to form an array list. Why array list? Because the return type is an array list, right? So array list of long type, and we'll have 4 values. So for n equals to 4, we'll make a array list of size 4, 0 1 2 3, and we'll place the value 1 and rest everything as 0, right? So it is written 0 1 2 3. So then, so I need to run a for loop 3 times, right? So 3 times, how can I generalize it? I can just write for I equals to 0 to I less than n minus 1. So n minus 1 would be nothing but 4 minus 1, that is 3. So it will run for 0 1 and 2. So it is running 3 times, right? Great. And I plus plus. Then what we have now, again a for loop would be there, right? And I have to travel from the last pointer. So I will say for j equals to n minus 1 till j greater than 1, and j minus minus j greater than equals to 1, because I just need to move from this index to this column index. I do not need to cover the 0th column because every value is 1 there, right? And I will just write that let's say dp of j plus equals to dp of j minus 1. And that's it, you are done with this code. Since there's a problem of overflow of 10 power 8, 10 plus 9 plus 7, so we'll have the associative rule here of percent mod, and everything will work, right? So what associative rule is, so you can write a plus b as a modulo m plus b modulo m whole ka modulo m, right? So we will apply this rule here and everything will work fine, right? So that was the whole logic. If you visualize the Pascal triangle in 2D and definitely will make sense that how we should proceed on, right? So that is it. Let us please pause this video here, try to code this approach by yourself, and meanwhile let us before proceeding to the coding section, let us discuss the time complexity as well. So what is the time complexity? We are using two for loops, it will be n square. What is the space complexity? O of n, right? And आप इसको लाइक इसका स्पेस कॉम्प्टी ऑफ एन स्क्वायर आपको लग रहा होगा, राइट, कि आप 2D एरे भी तो बना सकते थे, 2D एरे, बट अगर आप देखो कि to find a particular row we just need the previous above row, right? Like to find the row 2 I need 1, and to find the row 4 I just need the row 3 value, right? So that is why we have done space optimization as well. So O of n will be part of it. If you see the expected time complexity, it is written n square, right? So we have done a smart move that we have handled it. So that's the code here in Java. So that's the code in Java. We have a long mod, we have an array list, and we have filled the values with 0, and then we have set the first value as 1, and then we are iterating for n minus 1, and then we are traveling from the last column to the first column till the first column, j minus minus, and then we are just setting the values of that array of j is equals to array of j plus array of j minus 1. This is the associative rule is applied here, and that's it. So let us hit the submit button. So as we discussed, the time complexity is n square and n is 10 power 3, so definitely n square would be 10 power 6, which is less than 10 power 8, and that is why our code will get submitted here. Great, yeah. So all the test cases have been passed successfully. Let us switch back to the C++ code. So that's the same code as we have covered in Java and the dry run. So no need to I guess the code is self-explanatory, so don't need to explain it again. So that's it, we have done this question. And what else? So buckle up, guys. So after day 400 we'd be stopping the GFG POTD, right? And I'll be creating a Excel sheet to all the for all the users who are starting the DSA or revising the DSA. That Excel sheet would help you, or you can say the SD sheet. That this will consider the problems we have considered in GFG POTD and plus some standard problems as well, which we have not covered it yet, right? So I will make the list, and then after the day 400 we will start ahead with the development part, right? Because it's always DSA and development, not DSA versus development. To get more insights that what is important, how do we cover or how do we study in our placement journey, so I've had a webinar or seminar with my juniors at my SRM University. So not my, I'm an alumni there. So yeah, I had a webinar with the juniors which covers multiple questions regarding the DSA, like their question. You might have the same question as well. You can go through this seminar or the session to have your doubts clarified. So yeah, let us meet again in the tomorrow's streak. Till then, keep learning, keep growing. Bye bye, and take care, guys.